Okay, so hello everybody. It's good morning for most of you. It's a little bit of a good evening for me. So my name is Čelo Itasovic, and I'll be sort of emceeing the thing today, this presentation on WEF WISE. And I just want to say that we have some really nice speakers today, and I will advance. Let me see how many we have. 18. Just a second. So as we go through the presentation today, if you can please enter your questions, comments, and reaction into the Teams meeting chat, because we will monitor the chat, and then if you have a question for somebody specific, indicate that. So that we can sort of have a productive Q&A session. And today we'll start with an update. Last time we had a meeting that featured asset management, similarly that we're looking at CIP today. So Nohemy, you're on.
Yeah.
Introduce yourself a little bit. And yeah.
Sure. Good morning, everyone. Yes, my name is Nohemy Revilla, and I am a senior engineer, and I work for San Francisco Board of Utilities Commission, Wastewater Enterprise. And today I'm going to talk about, it is a small project. It was very interesting to me. I learned a lot, and it's we use we kind of study a little bit and analyze another way to do a risk-based approach. Instead of at the asset level, we wanted to do it at assembly level. So yeah, Chelo, the next slide. Yeah, so we, for the wastewater enterprise, we have this business plan from 2023 to 2025. And it has different kind of things. One of them is asset management. There's safety and there's other kind of goals. For asset management, we decided at the time to use a risk-based asset management system to inform the capital improvement program, right? So, we said, well, we will do this analysis on assets and decide what projects or what assets or what part of the different facilities need to be upgraded or updated or replaced or whatever was decided at the time. So this was in 2023. However, we in the past there was this document and developed that it was kind of the document that we have used for many years, where kind of lay the ground for doing risk-based approach. However, in this document, there's it is a very good document, but it didn't have a lot of the components that we wanted, and I'll talk about that in the next slides. But one of the things that, oh, sorry, Chelo. Well, one more thing, this document also talked about the likelihood of failure, right? Like how we do the risk kind of parameters, right? Likelihood of failure, probably you're familiar with that, consequence of failure, redundancy, and then, the asset risk score. So it had this component, but we decided while doing this to start with a consequence of failure, which is kind of related to the asset criticality. Okay, so now next slide, please, Chelo. Okay, so we started working with Chelo and Mike Burnett, and try to use the AIM group components, especially the process assessment and modeling, to look into this kind of, consequences of failure and how can we develop this, right? So part of this process assessment and modeling, as probably you're familiar with, has some parameters. So let's explain that in the next slide. So first of all, this is the the name on the top is that's how we name or kind of number our task orders. So we had several things that we did with Chelo and Mike Burnett, but the last one was kind of dedicated to the developing the consequence of failure. We decided to, by looking at the document, the original document I told you, we discovered that, or in there it was mentioned that whenever we have a consequence of failure, high consequence of failure, you can identify critical assets, right? So the consequence of failure is a key parameter for prioritizing likelihood of failure assessment. So one of the problems we saw was that likelihood of failure, it is related to condition assessment, and we take a lot of our time to do that, right? We have too many assets. So if you do it individually, that's kind of a problem. So that's why we decided to start with consequence of failure too, because it's a stable attribute. It does not depend on asset age or asset condition, right? So it's kind of it doesn't change over time too much. So as I said, we decided to apply the process assessment and modeling just to that part, to the consequences failure. Okay, so next slide, Chelo. So, I'm not sure if you're familiar, but the modeling, processes, the important components are, participants, what activities, like what are the steps, the information that you require, to execute the activities and make decisions. The decisions you have to make, right? The technology. In our case, we use SharePoint, we use Maximo, we use GIS sometimes. And, then also what resources do you need? Do you need a document? Do you need, a drawing? Do you need so things like that? And so also, you have to kind of lay down your desired outcomes and how you're going to measure that and kind of improve it based on those metrics. At the same time, we, like as I mentioned, when we read that 2013 document, we said, well, if we concentrate on assets, we are not going to solve this problem. We're never going to finish. Since 2013, we haven't done too many studies. We haven't improved. We haven't updated anything. We have used a couple of consultants to do a little condition assessment and things like that for all the asset, right? And at the same time, I and others from our enterprise went to a tour to one of another enterprise. So we went to Hetchy Water Power, which is our kind of a sister agencies or sister that belong to San Francisco PUC. And so that because they have a lot of the power lines and many of their assets in the forest, like close to Yosemite National Park, they cannot do condition assessment, right? So and then what they do is they lump together all their assets as assemblies. So that's when we kind of said, well, maybe we are approaching this in the wrong way. Let's try to do it as an assembly base. So that's how we kind of decided on this. So next slide, Cello. So the top, you don't have to read all this. I just wanted to show how what was developed under this task order. The top part of the slide shows what was included already in that 2013 document. What we wanted to kind of concentrate more is kind of how we could do step 2 of this business process. If you're not familiar, this is this is what we call the business process modeling notation. Probably everybody's familiar, but this is an ISO standard on how to model a process, basically, right? So step 2 is what we wanted to kind of concentrate on and develop in a very good detail for this process on the assembly-based consequence of failure. So determine or review the consequence of failure, the COF for assemblies. So that's what we had to start looking into. So next slide, Cello. So one of the things I wanted to say is that in Maximo, this is our CMMS, how we store our assets in our computerized maintenance management system. We have different things. See, 1 second. We have the way they do it is by process and sub-processes, right? And then the assets. So you can see that, we have a facility, for example, Southeast plant, then, some processes or chemicals, and then we have the assets, right? So we decide, and then the next slide, let me show you this. You don't have to read this, but this is how we decided on how to kind of lump all the assets together. So we have at the top Southeast plant, and then we have a subgroup there, and that is in orange on the top, on the second top, I guess. And then, on the left side, we have structure. So for example, normally we have it in, for example, so the secondary clarification process has a structure number, and we call that SCP-230, for example, or primary cementation as SCP-042. So we decided that the way we are going to structure our assemblies is by structure or the process. However, I have to say, sometimes depending on whether a group of assets, in this case a structure, needs to be further kind of classify a little in a little more detail because we have too many assets, or for many other reasons, we can do that too. For now, this is what we decided on, to group assets into assemblies by structure. So next slide, Cello. So at the same time, when we were doing this task order, we did actually a demonstration project just to kind of make sure that this is something that it's achievable and doable. So we, in the past, at the end of 2023, there was a reliability center maintenance study that was done for the BPSA oxygen generation. This structure is SCP-275, Southeast plant 275. So we did this because, first of all, we had a lot of videos and a lot of information for this particular study, and also we could compare. It could serve as a comparison between doing it asset by asset and doing it by assembly. And I know RCM is a little different from what I'm talking about today, but it has commonalities, right? You still do this assessment that I'm showing here. So one of the things, the differences is that when you do consequence of failure, when you do this analysis, but asset by asset, you have to concentrate on failure mode for each asset, right? So basically how that particular asset will fail. So because we group all this into an assembly, we had to do it as a functional failure. That's the analysis you do for this. So in this case, in this particular case, you know, for example, we consulted with an expert from UCLA and our own experts at our plant, and you know, kind of determined 3 functional failures. So one of them was the volume of the gas that needs to be produced, right? So this plant was designed with certain volume capacity, right? Or capacity of the gas that needs to be produced. And then also, it is related but not the same, is the oxygen required, the concentration, right? The concentration of oxygen required. So that's another kind of, it's a kind of a design, but it's also related to a functional failure. And then also the flow rate sorry, the second one in the middle there is that it fails to deliver gas at the required volumetric flow rate and concentration, and that is related to whether you have a leak or not. So everybody agreed that all of this you know, the expert and our experts, you know, they agreed that these were good functional failures to be represented here. And then the other thing we did was to so let's see, let's move to the next one. Yes, sorry. So we have, you know, I guess each group or facility or agency or when they do this, they have to different risk. We have risk matrices. I didn't show them here, but this is how they are shown in Maximo. We have 5 kind of areas that we concentrate on: operations, financial, regulatory, public, and safety. And then we have a numbering system, or like a scoring system. And that's, you know, so we go, when we did the study for this particular item or this particular structure or assembly, we went through all of them and discussed, right, and then assigned numbers or the scores for each one of these areas. And at the end, we decided that, you know, you can do this by average or the maximum, and for as a totalizer or kind of the rating for each functional failure, and decided on the maximum of that. Oh, sorry, I forgot to mention also that when you talk about functional failures, you also talk about, sorry, Cello, what did you say? Seems like you're talking. Oh, anyway.
I wasn't talking.
Oh, sorry. Okay. You assign a failure mode, right, to what you think is a more critical asset related to that functional failure. It's kind of confusing, but it does make sense when you go through that. So okay, so yeah, it's at the bottom here on the bottom left of the slide, you know, you go through steps 2.4, which is evaluate impacts of each functional failure, and then you consolidate the results and compare this, you know, the consequence of failures. So yeah, next slide, Cello. So I just want to say before I kind of make these conclusions that, yes, it took us a little while to go through, kind of understand the original document. Second, go through all the documents, or several documents from the Reliability Center maintenance study. But at the end of the day, it took us probably a couple of hours total to do this study or analysis, instead of the RCM study took more months, a couple of months or more, right? So you kind of shrink your time and resources into a lot less resources, a lot less time. So and it's doable, right? Because at the end of the day, you want to do this analysis to inform your capital program, right? Improvement program. Otherwise, it won't happen. It will take too much time. So assembly-based risk assessment is practical, and it requires fewer resources than asset-based assessment. And I have to say, asset-based assessment, we haven't done any or very little over this, more than 10 years. It increases the efficacy of risk assessment, and it helps target the assets that require risk assessment, right? Because you identify, with this way of doing it, you identify the very, very critical assets from the different structures or assemblies. And it's consistent with likelihood of failure analysis based on assembly age using Iowa curves. So I have to say this. This is the next one, the next thing that we have to develop, right? Because we have to do assembly-based likelihood of failure analysis, and do this business process modeling for that, because we haven't done it. But it will improve our way of doing risk assessment overall. So that will be next. Next slide, Angelo. So the recommendation is to continue and develop business processes for the rest of the steps, right? Implement assembly level risk assessment for PUC risk management using the develop risk assessment and consequence of failure business processes. And like I said, streamline the likelihood of failure analysis on, based on assembly rather than asset. And I think that's it. Any questions?
So please, if you can enter questions into the chat line, we will come back to the chat line. Thank you very much, Nohemy. We'll move forward. And then when we're done with the presentations, we will then be going to the chat line and answering questions. So thank you very much, Nohemy. Our next thing is a panel session about CIP, the challenges and opportunities, and I'll turn it over to Brian Persing.
All right. Hello, everybody. My name is Brian Persing. I am a plant superintendent for WSSC Water, just outside Washington, D.C. I run a 30 million gallon a day water resource recovery facility. We're also the site of our new bioenergy project. I've been in the industry for over 20 years, doing contract operations, startups, all kinds of things in different employers. So we've talked about risk, and we're going to talk about planning. So I'll briefly touch upon the impacts of daily operations. For the plant, CIP is how we fund and replace those big ticket items. So let's go to the next slide, Cello. All right. These projects help improve the plant's reliability, compliance, efficiency, basically rebuilding a lot of things from the ground up. So as the owners of the equipment and the staff needs to be involved and into the process, from deciding on what gets, what's going to be addressed, what's going to be done, but there are challenges, the aging infrastructure, limited budgets, the delays and whatever. And during this whole time, whether it's in the planning stages, when you might have something failing and you've gotten to it a little bit too late, or when you're in your project stages and you're implementing things, we've got to keep the plants running. We got to make sure that everything's taking place. Depending on how important it is, you're talking about, like working on a plane plane's engine while it's in the air. If you've got multiple engines, great. Taking one out is going to be an issue, but you can change operations and the other should support it. If it's a single engine plane, you can probably glide for a while, but unless you've got a really good short project or a really good pilot, you're gonna crash and burn. So what you've got to do in planning is come up with alternatives. Come up, a backup engine, a backup, something that goes into the planning and gets you going. I'll start with one of the biggest challenges I've gotten into with CIP projects is where I am right now at Piscataway. Back in 2018, they discovered that the plant had problems at high flows, and they had not placed the diffusers in the plant in years. And hey, we're having issues. So they went ahead and had a project all designed to replace all of our diffusers in all of our aeration basins in 2021. Like I said, we're a 30 million gallon a day plant. We were receiving 35 million gallons a day flows in 2021, and they had this project to take a quarter of the plant off at a time and replace things. So coming in, I inherited this project. I didn't get in on any of the planning. I'm like, okay, we're going to start it, but you guys understand we're gonna coast for a while, but then we'll probably be non-compliant. Our upper management didn't understand that. So the fact that we took a 30 million gallon a day plant, made it into a 23 million gallon a day plant and fed it 35, they're like, what's going on down there? Why are you non-compliant? We made it through half the year pretty good. So I thought it was great. But as expected, we lost nitrification. Everybody started second guessing the staff. Morale went down, and they went ahead and they after we were all done, they commissioned the study to have somebody do some modeling and go, oh yeah, the modeling shows that they would never have been compliant. And it's like, yeah, guys, that's what we've been saying all along, but they finally proved what we said. So what we've learned in these projects is, let's go to the next slide, Cello. Get staff involved early. Expect curveballs, communicate constantly, do that modeling. We were talking about modeling in the last presentation. Do modeling ahead of time, not what you're going to get and what you're going to receive, but what's going to happen in the middle. So you kind of know what's going to happen. Involve the plant, involve the staff, involve everyone, involve your regulators, because if you're not going to, it's going to be a rough time being compliant, they can be understanding, embrace the new technologies, as we're expanding our plants, it's been the same thing year after year. There's new stuff out there. There might be something that could help supplant the process while you're upgrading, and work together. CIP starts with boots on the ground, and that's the only way we can do better. I was nice and quick, and we'll go on to the next guy. Thank you, everybody.
Thank you very, very much, Brian.
Yeah.
Okay.
All right. My name is Perry Holland, and I am the Director of Comprehensive Planning at Metro Water Recovery. My department specifically is over our capital expenditure schedule, CIP, whatever everyone calls it. We also are over asset management. We are currently in the middle of starting up our AM, kind of a new asset management program. We've always done a lot of asset management activities, but I don't know that we've been great at having a formal program that we use all the data that's available to us. So that's another thing my department is over. We also do most of the facility plans within my department. We help manage those. And so in a nutshell, that's kind of what I do. I've been at Metro now for 15 years. Prior to that, my first 10 years of my career, I was with Montgomery Watson Harza, now Stantec, for the first 10 years. So it's hard to believe 25 years that I've been working since I graduated from Brigham Young University. And today I'm here to talk primarily about how Metro does capital planning at a really high level, and also how we look at prioritization of projects. So I'll start with these first couple of slides are kind of about planning. And when we look at planning, there's four main drivers. There's our regulatory drivers, things we have to meet our regulations. We have our asset replacement, so things that need to be replaced on time, so that we don't compromise our operations. We have our capacity needs, and then we have our mission support. So we have a lot of different projects that are used to address other things that are not necessarily replacement or capacity regulatory, things like safety, support facilities, things like that. Those are our four main drivers that we have. As far as our inputs to how we actually generate our capital expenditure schedule, certainly we have 9 programs at Metro. 5 of them are infrastructure programs. 4 are kind of what we call non-infrastructure programs. And like one of those programs is called the Continuous Improvement Program. Another one's the Safety Program. So we have 9 total programs though. And those programs a lot of times have different needs that they generate. And they basically, each of those programs owns a portion of the plant, so to speak. And they will input to us what needs they have. And we will work with them to put those on a list of things that we need to consider for our next capital expenditure schedule. Obviously, planning efforts, facility plans, any kind of master plan, we get projects that come to us from those. We take the previous year's CES and we have to update escalation, right? Right now, that's a really big deal, and it's a big factor. And then asset replacement is the other big bucket that we have to put in this funnel. And then in the end, we have to figure out how to prioritize all that. You can't do everything. Although I think sometimes Metro tries to do everything. Like probably a lot of places, we have a lot of ambitious people that are trying to do the right thing. And we a lot of times have way too many things on our plate. So we have the planning and prioritization step as well. Ultimately, all those come together to give us our next year's CES. We plan on basically a 10-year, 11 years if you count the upcoming years. So we kind of consider it an 11-year, but that's what we plan on. And then we have projects that go out to 20 years, but those usually aren't considered as far in the cash flow. Our approval process starts with the programs. We expect programs to kind of vet projects before they ever get to our board for sure, but we have a bunch of steps in between. We have what we call our Comprehensive Planning Work Group, CPW, which is in charge of recommending things to our program control group. So they'll take what the programs give, and it's kind of an upper leadership type group that will take a look at that. And ultimately PCG is more of our executive leadership, and they are the ultimate approvers. And then our steering committee is really what makes sure we have the right agenda for our board meetings. And then ultimately our board approves the projects. Next slide. So how do we make decisions? I would say that we use phase gates as our primary decision maker. I'm sorry, this is so small. Probably hard for you guys to see, hard for me to see sometimes, but we have different questions we ask in all these different phases. But all the phase gates you see, all those arrows are actually, could be phase gates that a project has to go through. That many times we look at it and say, are we okay with continuing this project? Are we okay with even starting it? We ask the various questions that you see below. So our business case is really about, is the project worth doing? Then we may decide that it's a good project, but the timing is still up for debate. So in the initiation, we basically will decide what we think the right timing is. We'll put it on our capital expenditure schedule. And then we will, when we get to the point where we're about to initiate, we'll ask the question again, is this really the right time to do this project? And then what other phases are going to be needed on this project? What check-in points is the way I would look at these phases, the phase gates. Once you get going on the project after initiation, we're in the planning. And so now we're talking about, we've gone through a design. Do we still feel like the value proposition is good? Are there any other questions we need to ask? Are you needing more money because of something you found in design? Can we absorb that or not? Those kinds of questions. And then the delivery phases, that certainly is where we have a lot of questions that we basically at that point you're building infrastructure projects for business projects, you're implementing them. And so basically making sure that we're meeting the objectives of the project. At that point, there's not a lot of turning back on a project when you're in delivery. So we've kind of made the decision to follow through once we get to delivery, obviously. We're committing the money. And then the closeout phase is just making sure we administratively close out a project properly with records, with financials, all that fun stuff. Next slide. So how do we do prioritization? This is like a multi-screen here. We'll go ahead and start with the first one here. So the way we do it is we talk about, we certainly are always talking about, does this line up with our strategic plan and our strategic objectives? The business case does a pretty thorough job of asking that question and trying to line up the objectives, the project's objectives with strategic objectives. When it's actually time to, start a project or look at if we can actually absorb it on the CES or add a new project, we'll use a graphic similar to this. And what I'd recommend you pay attention to on this is really the yellow bars. The yellow bars are kind of the amount of money that we have in our quote unquote bank. And it's basically money that we look at and say, okay, well, if we add this project and the cash flow associated with it, what will happen to our cash flow that our current proposed rates to our board are based on? And so we do it in a pretty simplistic manner from that standpoint. We put it in there. We say, okay, well, that's going to cause us to go negative in that year. What can we move around in order to accommodate it? Or do we need to not do this project at this point? So depending on what the priority is, we could decide not to do the project. If it's really high priority, we have to shift. Next part. We also look at the resources, staff resources. This is probably our biggest challenge with prioritization, in my opinion, is not taking on too many things. We struggle sometimes. We're really good at starting projects. We sometimes are not that good at finishing projects. And so this is one tool we have in Power BI that helps us to see if we're looking at a specific project manager, what are all the projects they're already managing? What about this area of the plant? Do we have too many projects in that area on top of each other? There's a lot of different questions we ask with this specific display. Next part. And then the way we do prioritization is really looking at all the different alternatives we have. If we have a project that comes to us that's important, we will look at active and future projects and say, okay, well, are there any projects that based on what we know about them could slide? Do they have to happen right now? We don't have the money in these years for that. For the new project, is there a project in that time frame that could slide if needed? So this is a pretty quick way to filter our current list, which right now is close to 200 projects, and be able to move things around as needed. We can also look at the phases, and if it's not in implementation or construction, then there's a decent chance we could put a project on hold if we absolutely had to. We don't like to do that and don't do it very often, to be honest. Okay, and then the last slide. Just some of the things we're looking at. We're trying to get better at this in general. I'd say the way we plan is pretty solid, but there are a lot of things that we need to get better at. For one, the number of steps it takes to go through phase gates has a lot of people complain about it. It's the red tape that no one likes. Sometimes we look at the red tape and say, you have to have a little bit of skin in the game. You can't make it easy all the time for people to start new projects that cost a lot of money. And so a lot of times the red tape is partly there just to say, look, you have to go through some effort. You have to do a business case. You have to put in some effort to get on this list. We certainly want to streamline the phase gates, though, especially at the end of projects. Part of the reason I think we struggle to close projects is we're not very good at, we have so many steps that it's hard for people to even keep track of what they're supposed to do next. And so we got to streamline that, make it easier. We're looking at a potentially a new CES tool. We currently have a spreadsheet that we use, and then we Power BI. That spreadsheet is essentially what we do for our CES. We're going to start looking at a different way to do that, hopefully. As far as prioritization, we want to do what most people I think are starting to lean towards, which is we want to actually score every project and have certain criteria that we would term really important strategically for us, that we can see with every project how it impacts that specific strategic goal. So we're in the middle of that. We haven't done that yet. That's why we're calling it improvement opportunities, but we have started that. And prioritization, the biggest concern I have right now with prioritization is really our inability to analyze workload for all of our staff. So that's a big part of what we're looking at too, is how can we do a better job really understanding if we have staff capacity to do projects, not just money capacity. And with that, I think I'm finished, Cello.
Thank you very much. Now, if folks want to enter comments into the chat line, it'll allow us to answer questions, whether today or in the next after the meeting. So I want to just also see if there are any raised hands, or if anybody putting it in the chat line would be probably most effective. And I don't see anything. I do want to mention, okay. There's a question for Perry. How many projects are on your CIP, and what percentage of your annual CIP are you spending per year?
Yeah, so our CIP is currently, we've kind of refreshed it, especially this year, so it's kind of in flux, but somewhere between 150 and 200 is probably the best I could give you. They're not all your infrastructure projects. Some of them are actually projects that relate to safety or continuous improvement. I know that's not considered capital, but that's the way our list is currently organized. The percent of our annual CIP we're spending per year is about 10%.
Okay, thank you. Any other questions before we move on?
There were some questions up above for Nohemy.
Okay, let me see. I saw that they were about asset management for Nohemy, and it was from Dan Baker. Dan, did you want to maybe just verbally say this so I don't have to read it?
Yeah, and I think Nohemy responded to my questions.
Okay.
So I think I got the answers. I mean, my questions were, one, how did you determine the level in the Maximo asset hierarchy that were assemblies, and whether you're tracking that? And then the other one was just related to you applying a similar kind of approach to the collection system.
Yeah, and thank you, Dan.
I have a question, actually. It seems like Dan worked on.
Yeah, I did.
It's
been a long time.
So were you a consultant, or were
you consultant with Carollo?
Okay.
Working with that group way back, more than 10 years ago, 10, 15 years ago.
Right, exactly. Okay. Yeah, so let me see. There was a question was about are you taking, so the collection system is different, right? We have a different they're using age for sure, but I think they are trying to refine the way they do their assessment because it's not working super well for them. But the last time we met, or because now we are going to the next 2025-2027 business plan, right? So we are thinking about that too. Like but I'm not sure. I mean, there are many more conversations that we need to have. They're trying to see whether, like lumping things or grouping things, segments of a pipe into assemblies, or, so it seems like it's a good concept. It seems like
Yep.
I guess they need to talk about. I am not part of the collection system group, but we definitely are talking together about that.
Yeah, and we were trying to like just keep things consistent in the approach between your vertical assets and the horizontal linear collection system. So it seems to me it would apply similarly, although a lot of it is doing the grouping through GIS or other kinds of ways of grouping those pipes into assemblies.
Yeah, I don't know. I guess we still need to kind of figure it out how that can be done.
Yep. All right. Thank you.
Thank you, Dan, for the question. And Nohemy, there's a question for you from Perry. Did you want me to read it, Perry, or did you want to just state it?
Yeah, no, I was just curious how we just spent a lot of time with our asset management program defining consequence of failure for all of our assets. And yes, it was a huge lift and it took months, for sure. And so I was just curious with the assembly type approach, do the individual assets inherit the assembly COF? And do you use the COF for asset replacement? Obviously, it sounds like you're doing that on an assembly level. But do you also use the COF to prioritize preventive maintenance programs or preventive maintenance work orders?
I think once we have everything, I think we have to see, right? Seems like from our analysis, we determined that, I guess the blower, it was one of the critical, I forget now, but one of the critical assets for that particular assembly. So we're going to, see critical assets under that analysis at the same time, because we have done just one. Seems like it works for us, but we have done one. We have to apply it to more, right, assemblies. My guess is that we are going to see, what assemblies are more critical than others, right? And at the same time, we're going to identify very critical assets for each assembly. But however, going back to your question, I think because we have to still develop the likelihood of failure based on the assembly at the assembly level, we still need to develop more things. We are kind of in the middle, right? We're not completely fully developed. So I don't know. I mean, I think once you have the whole at-risk score, maybe maintenance strategies are going to be developed too, but we don't have that yet. My guess is that, for potentially first critical assets under each assembly will receive a PM or more, the frequency of the PM and all that. Also, critical assemblies are going to be, kind of more important than others. But that's my guess, like an educated guess, I guess, for now. So we will see. We are not there yet.
Yeah, one quick input to that is we are looking at prioritizing corrective work orders based on consequence of failure. Mm-hmm. And we're looking at prioritizing preventive maintenance work orders using the overall risk equation, which is consequence, likelihood, and redundancy. Right. And so that's why I was curious. We prioritize different work orders based on different parts of that equation. So I just wanted to see how you were doing that.
I would agree. I mean, it makes sense what you're doing. Yeah, for sure. But you don't have all the equations ready yet. That's the problem.
Yeah. Thanks a lot, Simon.
And this was a bit of a pilot project. This was a very new idea, and the report was just finished recently. So it was a exciting thing to work on.
Definitely.
I don't see any more questions, but I will be posting this video to the and make the link available. Excuse me. And I also want to say, if you have additional questions or comments, you can send them to me, and I'll route them the best that I can. And we're planning for a meeting in June 2025, and figuring out now what we're going to do then. And I just wanted to mention that the work that Nohemy was mentioning, and that we're working on with, some other folks are using, originate from two different Water Research Foundation projects. I happen to be a principal investigator on both of these. The 5039 developed the framework and maturity assessment for the technology. And WEF 4806, which was quite a big project, looked at processes and change management and people issues. So now we're trying to merge these things, and we have some tools that have been developed. So that's sort of how all this stuff originated. And I want to say that I really want to thank our speakers, and give everybody just a little bit of a chance to to raise their hand and ask any questions before we wrap it up. Dan?
Yeah, Cello, just great job to the speakers today, and yeah, appreciated the info. So it was really, really good. In particularly on the CIP planning side of it, I think some of you folks are probably involved. There's another focus group within the utility management community on CIP planning and delivery. And that's led by Matt Bond, who's a colleague of mine. And then within that, there's also a project management delivery guidance work group within that focus group. So if you have any interest in that, I'll put those two in the chat and the contacts. If you're interested in just peeking in at one of those meetings, they usually meet once a month on I think like second or third Friday afternoon. So I'll drop that in the chat, and like I say, if you're interested in checking those out, come join the fun.
Thank you, Dan. And I want to thank everybody. We're just under an hour, and appreciate it. If you have questions, let me know. I'm just going to turn off the recording now. Hang on just a second. And want to